Kia ora. Quite a few students have been having some problems with inequalities and equality on the Desmos activities. So I thought I would just show you how these symbols work in mathematics. So what I'm going to do is I'm just going to open the standard Desmos graphing calculator. I recommend playing around with this a bit if you guys have some time, because it's got all sorts of useful little things that you can do. You can also use it, it's a little bit more open than the online activities, and that you can do whatever you want with it, zoom in, zoom out, and mess around. So the first thing I wanted to show you is the idea of this symbol here, right? This symbol means greater than. The best way to remember it is that the crocodile always eats the bigger number. So if I wanted to write something that's true, I could write that 8 is greater than 2. So that's in the form that you guys have seen it. But when you're doing it in something like a graph, you might say, let's say that y is greater than 2. So what that is showing on my graph is it's picked a line, and that line is just the line y equals 2, right? So you can see on the blue, I'll unclick this red one. So this blue line is showing me that at every point on y, well, at every point along x, y is always equal to 2. So at this point here, x equals 0, y equals 2. This point here, x equals 2, y equals 2. X equals 4, y equals 2. That's why this equation, y equals 2, looks like that. So it's just a straight horizontal line. So when I'm saying y is greater than 2, that is an area, and that whole area satisfies the equation that y is greater than that. At any point up here, the y value will be larger than 2. So let's get rid of this blue line, because you'll notice that it's got a dashed line here. And what that dashed line means is that the point 2 is not included. So if you want to include it, you're going to need to use the symbol y is greater than or equal to 2. So to do that on Desmos, I'm going to show you manually. It's going to be y greater than, and then you do an equals. But when you join them together on Desmos, it just does it automatically. So I'm going to do greater than, and then I'm going to hit equals. And notice that it makes that symbol for you. So this symbol just means not only is it y is greater than 2, it also includes that line where y is equal to 2. So that's what that means. So maybe we'll have another look at an example. So I want to shade in all of the space that is where x is greater than 4. So let's have a look at what x equals 4 would look like. That's a line such that along, no matter what the y value is, x is always equal to 4. So if I want to shade in everything greater than that, I'll just change it to this, x is greater than 4. Everything less than, it would be to the left of x, which would be shaded in. Or sorry, not to the left of x, to the left of 4. Remember, we can just put the equals there, and then it will include that line. Now, something that I can't really, let's see if I can. Y is equal to x plus 1. So these are linear lines. So we've sort of looked at inequalities, and I'm going to bring it back once I just show you a few more things. So if we want to have horizontal lines, y equals any value, you can add in a slider. So I'm going to call this one y equals a. Why is that going diagonal? That shouldn't be. Y equals b. What? It's doing it as if there's an x there, but I don't want an x. Yeah, okay. So you can add in sliders. So if you add in any letter that's not a y or an x, it will ask you if you want to make it a slider. So a slider means you can input different values for what this is, and it will move the line around for you. So any possible y equals line I can manipulate with this slider. So I could do the same thing for x equals a, and, oh no, why is it doing that to me? X equals a y. I can add a slider for a, and then I'm going to get rid of the y. I don't know why Desmos is making me have to do that right now. So this line is x equals 6.2. This is x equals negative 2.6. Right, so you can use sliders. They're useful in the future. But for now, if you want to do a horizontal line, it's going to be a y equals, and then wherever it is on y. If you want to do a vertical line, you're just going to do x equals, and wherever it is that you want to have that line. Then you get into linear graphs that are diagonal. So that's the formula is generally y equals mx plus c. Now I've added sliders. Maybe I should show you how I did that again. So see how these options come out? When m and c aren't anything, remember these are constants, whereas y and x are variables. So they change. So that's why they're on the axis, on the thing we call the Cartesian coordinates. So I'm going to add a slider for both m and c. So now when I zoom out, I can see what that graph looks like. Zoom out a little bit more for you. So on my graph here, we can see y equals mx plus c. So the gradient is controlled by m. That's the slope of your line. So when you have a really big one, it's going to go, so it's nearly pointing like straight upwards. But when you have a really small value, like 0.0001, it pretty much goes to being flat. So then anything in between, with 1 being the center of those, is where you get that diagonal line that's at that perfect 45-degree angle. So when you have the gradient of 2, it looks like that. 3, it looks like that. So that's gradient. And then c is the coordinate where it intercepts. So see how we've got this intercept happening here at 4.6? We call that the y-intercept. And that's what c controls. So that's a diagonal straight line. If you want the gradient to be going the opposite direction, right now we've got a positive gradient. How do I show you that on the screen? Positive gradient. If you want to get a negative gradient, what you need to do is you need to make it negative. So now any m value that has a negative value will become a negative gradient. So while we're in there, I want to show you how you can restrict domains and ranges of these functions. So let's just lock these in. Let's say that m was 2 and c was -1. So I'm going to get rid of my sliders now. So we've got this graph here, and it goes through that point. It's got that y-intercept happening at -1, and it goes, rises 2, runs 1. That's why it has a gradient of 2. Now, I mean, you guys should have done this back in year 11, but we're sort of taking it to a higher level now. You can restrict where that graph is happening, and you can use these squiggly brackets. So I'm going to just go keyboard. I'm going to show you where the squiggly brackets are on your keyboard. Which keyboard is going to be clear? I want to have something that's like high resolution so I can zoom in on it for you. Oh yeah, nice. So you can see on your keyboard, you've got these squiggly brackets over here. So these squiggly brackets are going to be how we control where the graph is happening. So we call that range and domain. So we can chuck our squiggly brackets in like that, and then we can control it. So if I want to control it on the horizontal part, if I want to do it by horizontal, horizontal is controlled by x, and we call this domain. So I chuck x in the middle, and then I put the numbers either side that I want to control it with. So maybe I only want to show you my graph from 0 up until 5. So I start with 0, and I say 0 is less than, chuck x in the middle, and then on the other side, I'm going to put 5. And then I close off my squiggly brackets. So that means my graph is only showing between 0 and 5. And in fact, you'll notice that the graph doesn't actually appear on 0. It doesn't show it very well. But if I wanted 0 to be included, I would need to write less than or equal to. That means 0 is now included. And the way we show that in graphs, I'm going to try and open a Jamboard real quick. The way we show that in graphs that we're drawing and it's not on Desmos is we do it by coloring in that point. So say we've got our straight line. So my one looks sort of like that, right? If I have less than, but I don't have the equal to, it becomes an open dot. But when I have the equal sign included, it becomes a colored in dot. So this one would be written as, I'd have the squiggly opening. I'd say 0 is less than x, which is less than or equal to 5. So see how the uncolored in one is if I have just a less than, so that means that I get a non-colored in one. And then when I have less than or equal to, that's when it starts becoming colored in. It means that that point is included. Okay, what else did I need to cover? I think that's everything for today. I hope that was useful and not too long. Ka kite.